Let's apply the definition of the theoretical probability to solve some problems. We agreed earlier the three examples are theoretical probability model, right? The first one, flipping a coin. We know the sample space is head and tail. It contains two outcomes. In that experiment, if we let A be the result that getting a head, and B is the result getting head and tail, both. Let's see how do we find the probability for the two events. Because we're computing the theoretical probability, so the formula would be K over N. N is the total number of outcomes in the sample space, remember, so N equals 2. Among the two outcomes, how many of them favor the result A or the event A getting head? Of course, 1, right? So that gives you half or 50% or 0.5. It's consistent with the result that we knew by common sense. P of B, formula, same formula, K over N. N is 2. What's the value of K? Among the two outcomes, how many of them favor the result that you flip a coin and you get both? You get both head and tail. Is that even possible? No, so none of them favor the result that getting a head and a tail, right? So the K is 0. The probability of B is 0. If an event has a probability 0, we say the event is not possible to occur. Example 2, rolling a die. That is a theoretical probability model. Sample space contains 6 outcomes. In this example, we consider the probability of A and B. A is the result that you roll a dice. You roll a dice and you get an even number. Result B is you roll a dice, you get a number less than 7. Okay, let's see the value of the probability. P of A, by the definition, equals K over N. N is 6, right? Total number of outcomes in the sample space. Among the 6 outcomes, how many of them favor the result that you get an even number? 3 of them. 2, 4, 6. So 3 over 6, reduce it, you get a 1/2. Think about you roll a die. You either get an even number, or you get an odd number, and equally likely. So that's consistent with our common sense again, right? Probability of getting an even number is a half, 3 over 6. Probability of B, by the definition, we have K over N. N is 6 again. B, you roll a die, you get a number less than 7. Among the 6 outcomes, how many of them is less than 7? If you get a 1, that's less than 7, right? You get a 2, also less than 7. 3, 4, 5, 6. All those numbers favor. All those numbers are less than 7. So all the outcomes, 6 outcomes, favor the result of B. So numerator is 6 as well. We got a 1. 1 is 100%. The probability that you roll a die and you got a number less than 7 is 100%, 1. If we have an event, the probability of the event is 100% or 1, we say the event is certain to occur, always occur. Whenever you roll a die, whatever the number you got is always less than 7. Okay? So example 3, roll 2 dice altogether once. We know the sample space contains 36 outcomes, they are equally likely. In this case, we consider the probability of A and B. A is you got a double sixes. Both of the 2 dice give you number 6. Result B is the occurrence that you roll 2 dice and the 2 numbers you got add up to 6. So we know the denominator, we know the formula. The denominator of the formula is going to be 36, the total number of the outcomes in the sample space. Numerator, among the 36 outcomes, how many of them favor the result of A? get double sixes. Sixes, yeah. So only one, right? Only one favor that result. So numerator is 1. 1 over 36. And also, you know, double sixes is an outcome. All the 36 outcomes are equally likely. Of course, the chance for one outcome to occur is 1 over 36. B, probability of B equals K over N. N is 36. K is the number of the outcomes in the sample space favor the result that the two numbers add up to 6. So 1, 1, the two numbers add up to 2, 1, 1, 2, the two numbers add up to 3. 3, 1, 2, 2, 1, 3, the in those three cases, the two numbers add up to 4. 4, 1, 3, 2, 2, 3, 1, 4. In those four cases, the two numbers add up to 5. 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. In those 5 cases, the two numbers add up to 6. If we keep going, you can see the number is the sum is getting bigger. 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. In those cases, the two numbers add up to 7 and 8 until here, double sixes, the two numbers add up to 12. So you can see clearly how many of them favor the result that the two numbers add up to 6. 1, 2, 3, 4, 5. 5 of them, right? So the numerator is 5. The probability of B, roll 2 dice, the two numbers add up to 6. The probability is 5 over 36. Okay? So that's the application of the definition, theoretical probability. I think you'll be okay with the theoretical probability model and the formula. So one fact is you need to see is the number of k, the value of k is no more than value of n. Value of k is no more than value of n. So k is less than or equal to n. And also k has to be bigger than or equal to 0, right? In this inequality, if we divide all the three parts by n, we would have the probability, which is k over n, is between 0 and 1. So generally speaking, regardless which type of probability we're talking about, generally speaking, probability is a number, is a value, the value between 0 and 1. The number, the value measures or describes the chance or likelihood of an event occurring. So probability can be seen as in a sense, can be seen as a measurement. The same with your weight, your height, your blood pressure. Those are numbers, right? Those numbers measure certain features of you. Same thing here. Probability is a number. It measures the likelihood of an event or the chance of occurring, the chance of occurrence of an event. So the number is objective. The number is objective. It's like your height after you have grown up. We don't consider when you get old, you get shorter maybe. But if you grow up, like then your height or your weight would be part of you, is something subjective, right? Or even your eye color, your hair color. Those are properties of you, a certain feature of you. Same idea, probability is also a feature, a property of an event. It is something subjective. It doesn't change because you wanted to change it, you know. So that's something very important for us to understand about probability. So that's the first definition for probability, is called theoretical probability. The second one is called empirical probability. You know, I'm a little bit scared here because previous video I made 30 minutes. Turns out I only recorded only like 10 minutes effective. So here, let me try to get another 10 minutes for this video. Second definition of probability, empirical probability. Another name, relative frequency approximation of probability. I think this name is even better. It is more detailed. Relative frequency approximation of probability. Do you guys remember relative frequency? Do you guys remember P? Sample proportion. Sample proportion. Do you guys remember this formula? P is the sample proportion. N is the sample size. X is the number of successes. So here we have another name for the sample proportion is called a relative frequency. Relative frequency. You would see that the sample proportion P or relative frequency can be used as a measurement to approximate the true value of the probability of an event. Let's look at an example. A recent research of 1,010 adults in the United States showed that 202 of them smoke. Find the probability that a randomly selected adult in the United States is a smoker. Let's think about the experiment here. Let's think about the experiment here. What kind of procedure that the research is applying? You can understand the experiment as you randomly select a person from the sample. You randomly select a person from the 1,010 people, adults. How's that sound? It's a simple experiment, right? How about this? It's not from the 10. Let me say that again. So the experiment actually is you randomly select an adult from the United States. Okay, that is accurate enough. So the experiment or procedure here is you randomly select an adult from the United States. That is the experiment because it gives you results. The result is either the person is a smoker or the person is not a smoker. So you basically only have two outcomes here. Again, outcome is the most basic possible result from the experiment. So the sample space of the experiment would be you get a smoker. The person that you selected randomly is not a smoker. Smoker and a non-smoker, right? So the sample space contains two outcomes. Are the two outcomes equally likely though? Very important. They are not. The two outcomes, unfortunately, are not equally likely. Otherwise, it's going to be a theoretical model, right? But this is not a theoretical model. It is a different model. It's an empirical model because the two outcomes are not equally likely. Okay, otherwise 50%, half of the population are smokers, and that's not true. We know that is not true. And the number of smokers are constantly changing. So we are talking about at one point, you are select a person, adult from the United States. So this is not a theoretical model. So the formula we have applied earlier doesn't apply here anymore. Then we need to find a different way to find the value for the probability of getting a smoker, right? And actually, it's not possible to get an exact value for the probability of getting a smoker. We could only estimate or approximate. Once again, one more time. It is not possible for us to find the exact value of the probability of you randomly select a person, adult from the United States, and and the person is a smoker, it's not possible to find the actual value of the probability for that event. We could only here to estimate or approximate. How do we estimate or approximate? We use the relative frequency. We use the sample proportion. It's a percentage, right? We use that percentage to approximate or estimate the actual probability. The formula here for the empirical probability would be P equals X over N. N is the number of sample or sample size. X is the number of successes in the sample. In this case, getting a smoker is a success. Alright, so what is N? N would be 1010, right? Sample size. And what is X? Number of successes. In your sample, there are 202 smokers, right? So 202 is going to be on the top. And you compute this fraction, you convert it, you would have 0.2 or 20%. Is a percent, 20%. Sample proportion. Sample proportion here is used as an approximation or estimation for the actual value of the probability. The theory supports the fact that we could use the sample proportion or relative frequency to approximate the actual probability is called law of large number. Law of large numbers. Let's read this part. As a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. The law of large numbers tells us that the relative frequency approximations tend to get better with more observations. This law reflects a simple notation supported by common sense. A probability estimate based on only a few trials can be off by a substantial amount, but with a very large number of trials, the estimate tends to be much more accurate. Now I have an analogy here to show you the relationship between relative frequency approximation, or P equals X over N, the sample proportion, and the actual value of the probability of the event. Let's say we have a table. We want to measure the length of the table, right? And the measurement actually is subjective. The measurement that you get might be different from the measurement I get for the same table. Even just for yourself, the result, the measurements you get by using different tools would be different, right? If you use the tool is very accurate. You would have a more precise measurement. So the measurement is subjective. I'm sorry, a measurement is objective. Depends on the person that measures the length. Also depends on the tool the person is using. And we are using the measurements to estimate or approximate actual length of the table. The actual length of the table is something subjective, right? Hold on. Which one is subjective? Oh, okay, objective. Sorry, this is objective. Maybe I misspoke that earlier. Probability is objective. Something will not be changed. Okay, something will not be changed. That is objective. Probability is like your eye color, your hair color, your height, your weight. Those are something objective, will not be changed. So those are so probability is the same thing. Measurements is subjective, depends on the person who measures and depends on the tools the person is using. The reason we could use the measurement to estimate the actual value of the length, because sometimes we don't just measure once, right? Because of the law of large numbers. We try to measure many times, like 100 times, or 1,000 times, and then we take the average of those values. We use the average to be the approximation of the actual value of the length. Same idea. If the sample space were the number of trials, let me explain what is number of trials. In previous example, the procedure is you randomly select an adult from the United States, right? That is one trial. That is one trial. And then if you repeat the trial again, you get 2 trials. And you can repeat the trial, you repeat the procedure over and over until you get a large number of data, or the sample that you get is large enough. So N here also represents the number of trials. So if the number of trials is big enough, then the proportion, sample proportion, would be closer to the actual probability, or the true percentage of the smokers in the population, right? So that is the large numbers, law of large numbers. Again, probability is something objective. Relative frequency is something subjective. It depends on the sample that you got. Your sample might be different from my sample, right? So this is the second probability.